The activity diagram has the classic features of logic structures and control flow, and is available for entities in the function class. It is part of the SysML representation set and is closely related to the EFFBD. The similarities between activity diagrams and EFFBDs are not coincidental. Not only are they working to address the same fundamental need, a more comprehensive representation of behavior, but the EFFBD notation was used for both guidance and verification by the SysML team during the development of the activity diagram. The net result is closely coupled representations that you can select from to best meet your analytical and communication needs. The activity diagram unambiguously represents the flow of control through sequencing of functions and constructs, focusing exclusively on structural control and ignoring the sequencing and synchronization aspects of the corresponding data flow. Rounded rectangular nodes represent functions. The flow of control is left to right. Diamonds and bars represent control constructs, the building blocks of behavior. As a function completes execution, flow of control proceeds along the branch lines to the next function or control construct. The black circle on the left edge represents the last function to complete before this decomposition begins, the source of control flow. The double black circle on the right edge represents the next function to enable when this decomposition completes, the sink of control flow. Each construct has a precise definition that prescribes how control will be passed within the construct and when the construct itself will end. Let's take a moment to overview what each of these constructs does. First up is the parallel construct. The parallel node is followed by separate branches that rejoin and terminate at another matching parallel node. The construct designates that all branches execute concurrently. Further, all branches must complete before execution can exit the parallel construct. The select construct designates a selection of the two branches. When execution reaches this construct, one of the branches is chosen and executed. None of the other branches are executed. Each branch can be assigned a selection probability using the right-click menu. A multi-exit function is a construct where multiple branches exit from a function and rejoin at a select node. This operates similar to a select construct where only one of the branches is executed. When an exit node is encountered, the rest of the diagram is skipped, and execution will move to the sync reference block. A loop construct consists of a pair of loop nodes that enclose a branch and are connected with a loopback line. Everything between the loops will be repeatedly executed in sequence. A loop is usually accompanied by a loop exit, which provides the mechanism for exiting a loop. Without an exit, the loop continuously executes. When a loop exit is encountered, the innermost loop is immediately terminated, enabling the construct or function following the loop. An iterate construct consists of a pair of nodes that enclose a branch and are connected by a loopback line. The line is automatically labeled with the name of the associated domain set entity. Everything between the iterates will be executed in sequence, the number of times defined by the domain set count attribute. A replicate consists of a pair of nodes that enclose a main branch and are connected with a coordination branch. This coordination branch is automatically labeled with the name of the associated domain set entity. The replicate construct is a shorthand notation for identical processes that operate in parallel. The activity diagram displays items as they are passed between functions. Inputs are data store items that have nothing to do with the control of the model. They simply represent data that one function outputs and another function receives as inputs. Continuing this logic, inputs also have nothing to do with control. This figure shows a data store that is output, then input. Notice the optional notation on the input arrow. When an item is required to be received by a function in order for the function to execute, this item is called a trigger. Notice there is no notation on the input arrow. Remember that the real value of modeling your behavior in an activity diagram is realized through exercising that model. The GENESYS Simulation Guide will help you learn to use the simulator, where you can examine your model to ensure it performs as desired.